Electric potential or electrostatic potential. This tells us about characteristic of a location in electric field. There is a space, in the space there is an electric field. There has to be a source of electric field somewhere, and because of that source there is electric field. Now in that electric field there is a point here. If we put a particle with an electric charge here, it will experience a force. Force is a physical quantity. Now if we put another particle here, we have to apply certain force. Okay. Now the characteristic of this point is given by a quantity known as electric field at this point. We know that. Now another characteristic we will study, and that characteristic is potential of this point. Electric field is a vector quantity and it is related to the force experienced by the charged particle. Potential of a point is related to energy received by, or the energy to a charged particle when that charged particle is placed at this point A. फिर से, if there is a charged particle and I place that charged particle at point A, I find that it has got energy 100 joules. If that charged particle I place at point B, then I see that it has got energy, potential energy equal to 60 joule. Then there is a difference between point A and point B. Which characteristic is showing this difference? Answer: energy is showing the difference. Okay. Now, who is having the energy? Answer: the charged particle is having the energy. If it is same charged particle, why the energy is different at B and why it is different at A? It is because of their location. It is because of their location. So this 100 here and 60 here I will call potential of point A and potential of point B. So what is potential? Potential is, listen carefully, potential is possibility of achieving energy. Possibility of achieving energy. If I place 1 unit charge at A, what is the possibility of achieving energy? 100 joule. If I place the charge at B, what is the possibility of achieving energy? How much? 60 joule. So I will say the potential of A is 100, potential of B is 60. I don't put charge anywhere. Still, A and B are having potential. Listen, the potential word is to be linked with location, not with the charged particle. It is linked with the location. A is such a location that whenever you place a charge, how much will be energy in that charge? It will achieve energy 100 because of A's location. B is such a location that it will get only up to energy of how much? 60. That is B's potential. In our day-to-day language, we use this word potential. In the market, if I open a stationery shop, what is the potential? Where is the good potential? Where? Location. Then we tell him, if you open a stationery shop in a street near the college, in a street near the school, the potential is good. Suna hai aapne? Potential is good means what? You will get lot of energy, you will get lot of money, you will get lot of sale, and there will be lot of achievements. That is potential. But who will get the potential? The stationery shop. but because of what? That location. So potential word is to be used with the location, and energy word is to be used with the charge which I place here. Understand? And that energy is potential energy, because at that particular point the charge is not moving, it's not having kinetic energy, so all its energy is potential energy. So potential is characteristic of a location, that is point. But potential energy is characteristic of a charged particle. Okay, one thing is understood very well. ये सब कहाँ हो रहा है? Where we are doing all this? In yes, चारों तरफ क्या है? Electric field. If there is no electric field, there is no potential. Understand? Okay. Now, so potential is characteristic of a location, a point, which tells us what? That if a charged particle is placed on that location, how much will be its energy achievements. Clear? Now, we would like to add with the energy another quantity, that is work. We know what is potential. Potential is the work done on a body. It is stored as potential energy in that particle, like we have seen in our earlier examples. A ball is taken up, it stores potential energy. Similarly, if I have a charged particle here, it has got certain charge Q, the strength of electric field here is E. This Q I want to bring from B to A. I want to bring the charge Q from location B to A, but what I find that it is experiencing a force. How much is that force? Q into E. That is the force it is experiencing. So I have to apply a force. Because of this force, what is its direction of intention of motion? Answer, along the E. I want to bring it from B to A. So I push it here with the same force QE and increase a little. It starts moving. I keep it here. How much force I have applied? Almost QE. Right? How much I have moved from this place to this place, B to A. So there is a force, there is a displacement, therefore there is a work done. Right? Force into displacement. So what I have done? I have done work. Work by applied force. In moving a charge Q from B to A. Work done B to A. This is equal to, if this displacement dr, then force multiplied by dr, force multiplied by dr, force multiplied by dr, or integration of all. That will give integration force applied into dr. This is dot product F dr, or integration. Integration we will do from B to A. This is work done from B to A. Okay, now another thing. Work done is done by external agency, applied force. If we convert it into work done by electric field. Okay, again, this is force applied. How much is this force applied by me? Answer is, whatever force was being applied by electric field, I have to apply the same force. I don't want any acceleration. Without acceleration, I want to move it. So, how much force I will have to apply? The force applied by electric field. Electric field kitna force laga raha hai? Answer, electric field is putting the force Q into E. So, how much force I have to apply? Q into E. So, but what is the direction? Applied force, force by electric field, force applied. These two forces are equal to each other but opposite in direction. So now I can write this, that work done from B to A is equal to minus F electric field dr. Is this point clear? So, this is electrical force dr, this is work done from B to A. This also I can write as, this is the first formula we get. If a charge is taken from B to A, the work done from B to A is equal to negative of electric force into dr. Now this I can write as work done B to A is equal to minus B to A, electrical force is Q into electric field dr. Right? Okay, now suppose the charge, when it is brought to the point B, it has got certain energy, potential energy. Why potential energy? Because we cannot place a charge at point B without doing any work. We have to do certain work because electric field goes up to infinity. From wherever we bring the charge, suppose I bring charge from here and I want to place it at B. So from this place to B, I have to move, and electric field is everywhere. So even from this place to B, I have to push it, do certain work, and I reach at point B. I have already done some work on it. When I stop there, where is my work energy gone? That is stored as potential energy in this charge particle. So when this charge particle is here, it has got energy. How much? U, potential energy at point B. Right? Now suppose I do a little more work, exert more energy and push it here. I have to do certain more work because I am going against the electric force. I do more work. That work is also stored with this particle, and now its energy is UA. So UA is different, UB is different. Why it is different? Because going from B to A, we have to do certain work. Right? So now these two potential energies are different. what is the difference in the potential energy, UA minus UB. According to work energy theorem, the work done from B to A is equal to difference. Final energy कहाँ पर? A में. Initial energy कहाँ? B में. This difference UA minus UB. तरीका समझ आया? हमने क्या फॉर्मूला लगाया? वर्क इज इक्वल टू एनर्जी फाइनल माइनस एनर्जी इनिशियल. इसलिए क्या होगा? B to A में फाइनल पॉइंट कौन सा है? A. सो एनर्जी एट A माइनस एनर्जी एट B. दिस इज देयर. नाउ एनर्जी एट A, एनर्जी एट B. If we divide it with this, so we have here UA minus UB is equal to WBA is equal to this minus Q EVR. These are the formulas. Okay. Now we divide it with Q. So what do we get here is UA minus UB upon Q is equal to work BAQ is equal to minus AB EDR. Now this is energy difference. This is equal to work done from B to A per unit charge. This work done from B to A, per unit charge, we call it potential difference. फिर से, what is the definition of potential difference? If we take a unit charge from point B to point A, then whatever work is done, that is known as potential difference, because that is difference of the energy on a unit charge. The difference of energy per unit charge will be known as potential difference. Potential difference. And this potential difference is what? This potential difference, we give it a name. The name of potential difference is VA minus VB. Why VA minus VB? Final minus initial. Very good. Final minus initial. VA minus VB. This is UA minus UB. This is work done from B to A, and this is according to that. Is this point clear now? पोटेंशियल डिफरेंस कैसे निकालना है? फाइनल पोटेंशियल माइनस इनिशियल पोटेंशियल. पर यूनिट चार्ज क्या लेना है? एनर्जी फ्रॉम फाइनल लोकेशन माइनस एनर्जी ऑफ इनिशियल लोकेशन पर यूनिट चार्ज. दिस इज VA minus VB. Now we have it here. VA minus VB is equal to work done from B to A per unit charge. This. Okay. If we want to convert it into E, we can always do that. That is E into dr. But first we will work on it. This is electric potential difference between 2 points. Amount of work done on a unit charge from one point to the other. So, now we come to the next derivation, and that is potential at a point. पोटेंशियल एट ए पॉइंट मतलब एट वन पॉइंट. अभी तक हमने क्या किया था? पोटेंशियल डिफरेंस. अब हम क्या कर रहे हैं? पोटेंशियल एट सिंगल पॉइंट. ओके, वी नो potential at infinity is 0 because E at infinity is 0. Now let the point B be at infinity. ये वाला पॉइंट B हमने ऐसा दूर करके कहां कर दिया? इंफिनिटी पे. अब VA माइनस VB की डेफिनेशन क्या होगी? द डेफिनेशन ऑफ potential difference VA minus VB is you bring a charge from infinity to point A and that will be the potential difference. Understand? Now let the point B be at infinity. Let point B be at infinity. Then VA minus V infinity is work done from infinity to A. What does this mean? What does this mean? Potential difference point A to infinity, but we know that V infinity is how much? 0. If V infinity is 0, then what we can write it? VA is equal to how much? This. Potential at a point. And now we will write the definition of potential at a point. This is the definition we have made because we have brought it with this definition. Electric potential at a point in electric field is the amount of work done in bringing a unit charge from infinity to this point, and we are simply doing the work of transporting it from infinity to this point. We are not using our energy to accelerate it. So if there is a writer who is very cautious, who will also write it without acceleration. Otherwise we may be spending some energy on acceleration, so he says no acceleration. So initial and final velocity is same, so there is no change in kinetic energy and all the work done is converted into potential energy. This is what we want. Okay, so this formula is basically, this is a formula of potential energy, potential difference. Potential difference में से हमने क्या चालाकी की है? In this potential difference, VB, we have made it V infinity because we know V infinity is 0. So accordingly our definition has also changed and now we are doing work from infinity to this point. Now the thing is still how to measure this potential. The answer is we can always find a derivation how to measure it. The electric field, what is the source of an electric field? Answer, a charge is source of an electric field. Okay, so if there is an electric field due to a particular charge, then how can we find out potential at a point due to that charge? We will do a derivation for that. Okay. Before that derivation, we can do one thing more, and that is this. This is what? VA minus VB. Potential difference is energy difference. What is per unit charge? So this is something, work done is the difference of energy according to definition of potential difference. Electric potential difference between 2 points, VA minus VB is UA minus UB per unit charge. You bring this Q here, and what do we get? This formula. This is what potential difference, and this is energy difference or the work done. Okay, potential charge, energy difference. This helps us to find out energy difference between 2 points if we know the potential difference. A charge of 2 coulomb is brought from a point of 100 volt to a point of 200 volt. How much work I will have to do? 200 joule. Clear? फिर से, there are 2 points in electric field. This point has 100 volt potential and this point has 200 volt potential. If I am bringing a charge from this point to this point and the charge is 5 coulomb, how much work I have to do? Work. Yes. You understand now? This is how we calculate work done. What is the difference of energy level between the two? Same thing. Work is energy level difference. So, this is the practicality of this formula. If we are given potential, then we can always find out work done. In our household electricity, we are getting a potential difference of 220 volt. That means when one charge goes from positive to negative through the bulb, plus to minus through the bulb, 1 coulomb charge, how much work it will do? What is the potential difference? 220 volt. How much is the charge? 1. So how much work it will do? 220 joule. Everything in SI system. So whenever 1 coulomb charge goes across our socket, through the bulb, through the fan, how much work it is doing? 220 joule, because we know the potential difference, that is VA minus VB, and we know the charge. Right? We don't use this formula because we have better formulas in current. Charge Q we cannot measure. I am simply telling you the calculation. In electrostatics, we will do this calculation. If a charge particle is brought from this point, put at this point, how much work is done? Answer, this much work is done. Understand? So this is a very versatile formula to find out work done on the basis of potential difference, because potential difference is defined in this way. Okay, now this potential difference, we want to relate it to that charge which is creating electric field. Like we have a charge here. There is a point charge Q placed here. There is another point A at a distance R. We want to find out what is the potential at point A. So potential at a point due to source charge Q. What is our definition? We will bring a unit charge from infinity to point A. Whatever work is done, that is potential of point A. Okay, let's do it. Let there be any point here at a distance x. यहाँ पर हमने एक छोटा सा चार्ज रखा, टेस्ट चार्ज स्मॉल q, इस पर कुछ फोर्स लगेगा, ठीक है। देखिए, इसको यहां से हमने फोर्स लगाया और थोड़ा सा पुश किया। कितना पुश किया? dx। क्यों? क्योंकि हम नहीं चाहते कि फोर्स की वैल्यू बदल जाए। जैसे जैसे हम इधर आएंगे, फोर्स विल गो ऑन changing, it will go on increasing. We will not be able to calculate work done if the force is increasing. So we use the calculus formula. So how much is the force? This is the force, and how much is the small displacement? dx. Okay, then how much is the work done? We know the work done is f dx. This is our formula. Now we put the values here. That is, dw is equal to integration f dx. How much is f? 1 upon 4 pi epsilon naught q upon x square, and dx f dx cos theta. F into dx. Okay, we are applying force in this direction and dx is also in this direction. ठीक है? Okay, so this is a small work done by us. Now, how much work is done according to our definition? What do we want? The total work done from infinity to point this. What is this distance? R. So therefore total work done from infinity to R is equal to integration infinity to R, and this is 1 upon 4 pi epsilon naught q upon x square dx. Right? So again, work done from infinity to R is equal to, constants बाहर ले लेते हैं, the constants will come out, and what is to be integrated? Correct? This is equal to x to the power minus 2. What is it? Integration plus 1. So x to the power minus 1 upon minus 1. This is infinity to R. This is equal to, minus 1 you put out, so this will be minus 1 upon 4 pi epsilon naught q upon q, and in the bracket we have it 1 upon x infinity r, that is equal to 1 upon 4 pi epsilon naught q, what will be in the box? 1 upon infinity minus 1 upon r, and there is a 1 minus outside, minus 1 upon infinity is 0, this minus and this minus will become plus, so what do we get it? 1 upon 4 pi epsilon naught q upon r. Okay? And now this small q you bring on this side, so what do we get? Here, work done from infinity to r per unit test charge is equal to 1 upon 4 pi epsilon naught q upon r. And what is this? This is definition of potential at distance r. So this is potential at distance r. This is equal to 1 upon 4 pi epsilon naught q upon r. This is our derivation. ठीक है? Potential at a point at distance r from the charge q. This complete derivation you must remember by heart. छोटा सा एक इसमें डिफरेंस देखिए. Here yes, minus 1 upon 4 pi epsilon naught q infinity to r. We have brought it from infinity to r, so this is 1 upon infinity minus 1 upon r. Suppose we have not brought it from infinity, we have brought it from the distance r1 to distance r2, then what it will be? 1 upon r2 minus 1 upon r1. ठीक है? और अगर इस माइनस को अंदर ले जाएंगे तो क्या हो जाएगा? 1 upon r1 minus 1 upon r2. 1 upon r1 minus 1 upon r2, and that will be what? Work done from r1 to r2. फिर से अब मैं उसको लिखता हूं. से ये सीक्वेंस याद रखिए. If this is 2 and 1, this is 2 and 1. If this is 1 and 2, this will be 1 and 2. And remember again, infinity to R. Work done from infinity to R is equal to potential difference R minus infinity. ये होता है. सीक्वेंस देखिए, वर्क डन इन्फिनिटी टू आर, पोटेंशियल डिफरेंस आर टू इन्फिनिटी इज इक्वल टू क्यू अपॉन 4 पाई एप्सिलॉन नॉट. यहां पर क्या लेना है? देखो, आपका रिजल्ट यही आया ना, फाइनल रिजल्ट कहां आया? ये इन्फिनिटी टू आर, क्यू अपॉन आर, क्यू अपॉन आर, ये कैंसिल हो गया. इससे आपको क्या याद रखना है? V पहले कौन आया? R. यहां भी पहले कौन आया? R. ठीक है. अगर मैं इसको R1 R2 कर दूं तो यहां पहले कौन आएगा? R1, then there will be R2. Initially R1 R2. If this is final, this is initial, then this is final, this is initial. So some writers are using it this way: V final, V initial. Work done from initial to final. Initial to final position is equal to work done initial to final position per unit charge is equal to potential final minus potential initial. This is equal to Q upon 4 pi epsilon naught, and this is 1 upon, which position is this? Final, and minus 1 upon initial. This is equal to, where is the relation with E? Here is the relation somewhere with E. Integrate E dr R1 R2 minus. Now you have this 1, 2, 3, 4. Okay, so whichever format you become convenient for you, remember in all this format. But what you have to remember is the relation between work done, potential difference, charge, and that is electric field, and is equal to, एक और quantity छूट गई, what is that? Yes, U final minus U initial per unit charge. So 1, 2, 3, 4, 5, this you have to remember. What is EDR? EDR. DR is length, E is electric field. In some place, if there is electric field, here there is electric field, and I draw a path over here this way. This is A, this is B. If I bring a charge in this way, then how much work has to be done? The answer is, at every point, if I draw this straight line, this is dr, this angle is theta, and this length theta, this is how much? Dr cos theta. This, if dr theta, dr cos theta. So what do we have it here? E into dr. Work done is equal to, work done is equal to force into displacement integration. Now EDR is dot product. Due to this dot product, what this will be? Q E dr cos theta. Now if this is dr, then this line is dr cos theta. Let's call it dl. This is dl. Now if we go by this, dr cos theta, 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 what we get? This total dl, and this is a straight line. So this we can write as q e dl, because dr cos theta is equal to dl, and this is integrated. Now this thing EDL is known as line integral of electric field. What is that? Line integral of electric field. This is work done, force into displacement. This is work done. और ये कहां से कहां तक हमने लिया? A से लेके B तक. ये अब इससे एक बहुत ही इंपॉर्टेंट कंक्लूजन हमारा निकलता है. ये ऐसे ऐसे हमने लिया, ये DLI. अगर हम इसको ऐसे लेते तब भी हमारा रिजल्ट EDL आता, बिकॉज एवरीवेयर dr cos theta is equal to dl. इसका मतलब ये है, this means that if a charge is brought from A to B by this path, by this path, and by this path, the work done is always EDL, integration EDL. There is no change. Such work done, if it is independent of the path, then the force is known as conservative force. So electric force is a conservative force. This is very important. इसको लिखिए. Work done is independent of path. Therefore, electrical force is conservative in nature. ठीक है. अब एक छोटी सी चीज यहां देखिए. हाँ जी, हो गया. ये हम सब क्या निकाल रहे हैं? वर्क डन. ठीक है, वर्क डन A to B. अब अगर ये वर्क डन, ये वाला Q हम इधर नीचे ले आते, बिकॉज इट्स ए कांस्टेंट. सो व्हाट दिस विल बी? वर्क डन पर यूनिट चार्ज. और वर्क डन पर यूनिट चार्ज क्या होता है? पोटेंशियल डिफरेंस. सो दिस इज VA minus VB is equal to AB EDL. And what is this? This is line integral. So write a statement. पोटेंशियल डिफरेंस VA माइनस VB. पोटेंशियल डिफरेंस को हम और क्या लिख सकते हैं? DV. सो DV अगर उसको हम B to A करेंगे, देन दिस इज माइनस EDL. और E इज इक्वल टू, सॉरी, E डॉट dr. और E इज इक्वल टू माइनस dV बाय dr. This is again a very versatile formula, but we will take it in the next class in detail. Okay, so we will close it today.